So in this first video, we're just going to set up some of the modelling assumptions that we make when dealing with connected particles. So as you can see in this diagram, I've got two particles that are connected by a string over a smooth pulley. Now the string is light and inextensible. And in your exams, you may be asked by the examiner what effect the light and extensible string and the smooth pulley has on the system and your assumptions. So if we start with the string is inextensible. That means that the acceleration of the two particles at each end will have the same magnitude. Obviously, you could imagine if the string was elastic and we released the system, you'd have the particles bobbing up and down at varying accelerations. So what we can then say is we can annotate the diagram with an acceleration that is the same on both sides. Now, if we talk about the string being light, that means the tension in the string will be constant along its length. We don't have to take into consideration the weight of the string itself, and also the pulley being smooth. That means that the tension in the string on either side, it will be equal. So they're the main modelling solutions that you'd be asked to recount to an examiner. So please make a note and remember those. Now the only thing we'd normally add now is what would the masses of the particles be. That's how we would then go on to work out what the tension acceleration would be in these situations. So for as a brief example here, I'm going to mark the left-hand particle as being 3 kilograms and the right-hand particle being 5 kilograms. Now that's been done deliberately because if you notice earlier in the model, I put acceleration as going up on the left and down on the right. And obviously if we used our common sense, we'd know that if this system was released, the 5 kilogram particle would drop and the 3 kilogram particle would move up. Similarly, a lot of people ask about why the tension acts upwards in both situations. Well, obviously with the 3 kilogram particle, we're going to have a force of 3g acting down because obviously that is a weight that's been dragged to the centre of the earth by gravity. So using F equals ma, 3 times g. And obviously on the right, we have the 5g. Now, in terms of the tension's constant throughout. But if you were observing just the 3 kilogram particle that's been pulled up, there must be some force exerted by the 5 kilo pulling it over the top. So that'll be the tension that's in the string. Similarly, the 5 kilogram particle receives a resistive force from the 3 kilogram particle. So again, that is the tension in the string as well. So both tensions should act upwards. In the main, this is how we would have our model set up when using a connected particle